Let's just recap the key ideas. Ions form when atoms lose or gain electrons. And why are they doing that? To get the stable noble gas electronic configuration. Once the ions are formed, then they attract each other and an ionic bond is created between the ions. It's the electrostatic force of attraction between the oppositely charged ions. The ions all get together and they form a three-dimensional regular structure, which is called a crystal lattice of alternating positive and negative charges. And ionic bonds form between metal ions and non-metal ions. If you've got the charges on the ions, then you can use those charges to work out chemical formulae for ionic compounds. So let's have a look at a periodic table and let's have a look at some of the ions we might come across. Remember, the group number gives us the number of electrons in the outer shell. So if we look at hydrogen, for example, it has one electron in the outer shell. So when it forms an ion, it loses that electron to form H+. Sodium is another example of an element or an atom that's got one electron in the outer shell. So when it forms an ion, it loses that one electron to get a noble gas electronic configuration, and it forms Na+. Let's look at group 2. The example we'll use is barium. So barium has got 2 electrons in the outer shell. To form an ion and achieve the noble gas electronic configuration, it loses those 2 electrons and it forms Ba2+. Aluminium's in group 3, loses 3 electrons to form Al3+. Carbon, which is here, and also silicon, we don't write ions for carbon and silicon because it's not possible for them to lose or gain 4 electrons to get a noble gas electronic configuration. They don't form ions. They do something else, which we'll talk about soon. In group 5, we've got nitrogen here and we've got phosphorus here, and phosphorus will gain 3 electrons to get a noble gas electronic configuration. So phosphorus, it's got 5 electrons in the outer shell. It gains 1, 2, 3, and it achieves the noble gas electronic configuration of argon, P3-. Oxygen, it's got 6 electrons in the outer shell. It gains 1, 2 to become neon, to have the electronic configuration of neon. And obviously, because it's got 2 extra electrons, it has a charge of 2-. Chlorine, group 7, to get a full outer shell, it gains 1 electron, becomes chloride, Cl-. Here come some exceptions now that you need to learn. Stanium and plumbum, tin and lead, obviously known in Roman times. Tin forms Sn2+ ions, it loses 2 electrons, and so does lead. Lead loses 2 electrons to form Pb2+. You need that information to write formulae involving those elements. Let's look at the transition elements, which are in the middle here. We'll look at zinc. Zinc typically loses 2 electrons to form Zn2+. And here come a couple of special cases. Silver first. Silver loses 1 electron to form silver+, Ag+. And now copper. Copper can either lose 1 electron to form Cu+, or it loses 2 electrons to form Cu2+. That makes copper special. So we often have to indicate that in formulae. So copper 1 is Cu+, and copper 2 is Cu2+. You may have heard of copper 2 sulfate, and that means that the Cu2+ ion is present. The same is true for iron. These ions from iron are the 2 possibilities that it has to get some kind of stability. So in the case of Fe2+, it loses 2 electrons. In the case of Fe3+, it loses 3 electrons. So you get Fe2+, ion 2, and Fe3+, ion 3. And these are examples that you must learn because you'll need them. Okay, so using that information, you can try and work out the chemical formulae of the compounds indicated. Remember, these are all metals and non-metals. So ionic compounds form between metals and non-metals. Once you have the formulae, you can check them. They're really easy to find. Check them to make sure you have the correct formula.